Have a nice day. My name is Okan Özkan. I am the R&D and Business Development Director of My Technic, MO Technical Services, which is established in Istanbul. This is a hangar space. Now I will talk about the sustainability of electricity vehicles. There's an analysis of environmental and social impacts of electrical vehicles. Is it myth or reality? Here I will introduce to my technique first, and we will talk about understanding electrical vehicles and their sustainability, environmental impact of electrical vehicles, economic and social dimensions of electrical vehicle adaptation, and lastly, we will talk about myths versus realities of the electrical vehicles sustainability. Here, this is my technique, which is established in Sabiha Gökçen Airport, Istanbul, Turkey, in 2007. It has the capability of 12 narrow-body aircrafts at the same time, maintaining them, and 8 wide-body aircrafts. We had lots of certificates from FAA, CAAC, Chinese Civil Aviation, Turkish Aviation, EASA, UK, and plus 32 authorities. Additionally, we had the certificate of EASA Part 147, which is training center. And here we had the capability on the workshop sites. We can maintain the aircraft components, electric and electronics things, emergency equipment, hydrostatic equipments, and also regulators, wheel and brake shops. We had hydraulic shops. We can calibrate our tools, and also we can give the service to the outside of the facility. We had a machinery shop, which manufacturing or required ground support tools. We had laminating shop, which is laminating the change laminations of the side walls. And we had a textile shop, which also support our customers on textile sites. Additionally, we had an engine workshop, which had the capability of CF6-80 and CFM56-8 engines, maintenance and repair. Additionally, we can engine performance restoration, we can do that, and we can module repair and change there. Here is the main subject of we're going to turn to the main subject. First of all, we have to understand the electric vehicles and their sustainability relations. Electrical vehicles and if you look at the electrical vehicles and TK technologies, we can see that automobiles powered by electricity stored in batteries instead of fossil fuels. We are shortly call them EVs. Using the electric motors for propulsion help us to the higher efficiency and zero tailpipe emissions. On the K technologies using on that EVs, battery systems, mainly 3 battery systems is using on the sector. First one is lithium-ion batteries, high density and dominating today's buzz market. The second one, solid-state batteries, is much newer than the comparing to lithium batteries. It's safer and next-gen storage capabilities. And lastly, the BMS, optimizing the charging, safety, and lifespan. The second part, electric drive systems we are using here. The motors, PMSMs, and induction motors are using to the electric vehicles. We are using the inverters because we are storing the power as a DC, and it has to be converted to the AC for on the using side. And on the electrical vehicles, also we are using the regenerative braking system. It recovers the energy while braking. The charging infrastructure we are using for the electrical vehicles, as we know that AC chargings, level 1 and level 2s are using in the home and workplaces. DC fast charging stations, it can be charged 80% of the vehicle within 20 to 40 minutes. And wireless charging, using inductive systems and emerging systems to wirelessly charging this all vehicles. They can be using on those sometimes on the home applications. And now some European countries testing to the wireless charging roads on their highways. And for electrical control systems, we are using inverters, converters, and controllers there. Smart energy management and grid integration is important here. And lastly, on the connectivity and digital technologies, if you look at that, vehicle to grid is a new subject on the electrical vehicles. What does it mean? This means that the vehicle give back their unneeded energy to the system to reusing. And the other things is IoT and telemetric sites. The vehicles remotely monitoring and using that remote monitored sensors, we can develop the predictive maintenance and using the AI optimization. In context of transportation, if we explain the sustainability, we are minimizing the environmental impact of the transporting on our vehicles. Sustainable transport seeks to reduce harmful emission and lower pollution levels in urban and rural areas. Conserving the resources, also another subject. Efficiency use of energy and materials supports the conversion of the natural resources in the transportation system. Promoting sexual equality, transportation sustainability ensures accessibility and affordability for diverse population and communities too. If we compare the electric vehicles with the conventional vehicles which we are using now, on the environmental side, if you look at that, electric vehicles had zero tailpipe emissions, depends on the electrical mix, but on conventional vehicles continues to generate carbon dioxide and NOx emissions. On the energy efficiency side, the engines directly connected to the wheels, so we can use the power of 70 to 90% of the energy directly on the wheels. But comparing to the, if you look at the conventional vehicles, we see that 20 to 30% of the energy can transfer into the wheels. On the operating cost, lower fuel and maintenance costs we had on electrical vehicles, but comparing that, method of global refueling network is an advantage on the conventional vehicles. And on the life cycle challenges, we see that battery production and recycling had an issue. On the other hand, on the conventional vehicles, fossil fuel extraction and dependency, another issue on the commercial sites. What's the environmental impact of electrical vehicles? Still, I had a comparison here. On raw material extraction side, electrical vehicles high impacting on the mining lithium, cobalt, nickel for batteries. And in the other hand, on the commercial side, all extraction and refining is another issue. Manufacturing side, higher emissions to the battery production is an issue for the electrical vehicles. Normally, we are seeing that on the emissions is low for the user side, but on the manufacturing side, we see that higher emissions there. On the conventional vehicle side, lower manufacturing footprint we have now and engine complexity. Use phases, real tailpipe emissions depends on the electricity means, and conventional vehicles continues to generate carbon dioxide, NOx, and particulate emissions. End of life side, but the recycling challenges generate hazardous waste risks. And on the conventional vehicle side, scrap metals recycling well established now. On the battery production and recycling challenges, if you look at that, resource intensity, lithium, cobalt, and nickel mining with higher environmental footprint generate higher environmental footprint. On the ethical concerns, labor issues in cobalt mining in regions. And carbon footprint side, battery manufacturing accounts up to 40% of the EV life cycle emission. On recycling challenges, low recycling rates we have now, currently less than 5% of EV batteries are recycled. Technical barriers, complex chemistry, which manufacturing using on the manufacturing of the batteries, generate cost recovery processes. And infrastructure gaps we had because of the recycling that batteries, lack of large-scale recycling facilities isn't required. On the future directions, hydrometallurgical and direct recycling is needed, promising but not yet scalable yet. Circular economy policy side needs to close the loop and reduce resource dependency. And innovation and regulation sides, collaboration required between industry, academy, and governments. And if you look at the impact of air quality and urban environments effect, positive impacts of e-waste are zero tailpipe emission, reduce in carbon dioxide and NOx particulate matter, and noise reduction, quiet streets improve urban livability. Cleaner urban air direct benefits of public health, especially in the dense of cities. Remaining challenges are upstreaming emission. Power plants may still pollute if grids is fossil fuel dependent, and we will see that effect in the following slides. Now, extinguished pollution, tyrant break wear contribute a particulate matter. It is continue. Urban health effect, increased electricity demand may stress the grids. On the long-term outlook, renewable integration is required to grids amplify EV benefits. Urban planning strategy, synergy, EVs combined with public transit and smart cities to maximize the impact. Health benefit size, lower rates of asthma, cardiovascular diseases, and overall better air quality. If you look at the economic and social dimensions of electric vehicles adaptation, as we know that initial purchase of the EVs, higher upfront costs due to the battery now, and ICEs generally lower purchase prices. Operational cost side, EVs are lower fueling costs, electricity versus gasoline diesels, but in the other hand, we have to focus on the electricity unit prices increase, and it's getting higher. But comparing to the ICE, higher fuel expenses over lifetime. On the maintenance side, EVs fewer moving parts, so it requires less maintenance. They are not linked to the oil changes, not for example. And ICs frequently service requires frequency servicing, oil filters, extinguished and transmissions. On the battery replacement side, EVs battery lifespan is approximately 8 to 12 years, and manufacturers say that 150,000 to 250,000 kilometers. And the replacement cost of these batteries approximately 25% to 35% of the purchase price now. On critical factors in long-term ownership economics. Sorry. EV's total cost of ownership is competitive with the 5 to 8 years if battery replacement is not required during the ownership. On the EC side, cheaper upfront, but highest operational and maintenance costs over the lifetime. Accessibility and infrastructure development side, affordability EVs are still more expensive upfront, but costs are declining. On equity concerns, limited access to lower income groups without subsidies. On geographic gaps, rural and remote regions have fewer EV options and charging points now. On infrastructure development side, charging networks, expansion of public and private charging stations is critical now. And grid capacity, in current situation, we have to improve our grid capacity, means handle increased electricity demand. On standardization side, universal connections, payment systems, and interoperability is required for supporting the EVs. On long-term outlook, policy support is required, subsidies, tax incentives, and public investments to drive adaptation. A urban and rural divide, bridging gaps with targeting infrastructure projects. We have to improve the grid. On the integration side, linking EV synergy with renewable energy and smart grids. Another effect of the social effect of the EVs, new job creations, new industries generating using the EVs, which used by the EVs, battery production, recycling, charging infrastructure, for example. Technical and services is required. New EVs are new vehicles, require software development, smart grid integration, and telematics. Green energy sector is improving now. Expansion of solar, wind, and storage projects are generating. Potential social change starts, workforce translation, decline in fossil fuel-related jobs, rise in EV and renewable jobs now. Urban development side, cleaner cities, reduced noise, healthier communities is generating. Equality chains ensuring access to EVs benefit across the income and regional divides. On the long-term impact, economical growth, ecosystems are driven in innovation and investment. Cultural shifts, adaptation, sustainable lifestyles, and mobility choice. Global competitive side, countries investing in EVs leading in green technology markets now. Now, what's the myths and relatives about the electrical vehicle sustainability? As I said that, okay, we are using the electrical devices, but on the other hand, if we compare to the electric generation sources report, approximately 65% of the electric generation still use the fossil fuels like coal, oil, and gas. In the other hand, which we are defined as the clean energy, wind solar is 15%, hydropower is 14%, and nuclear power is counting in the clean power sites now 9%, and the others is 1%. Common misconceptions are EVs are zero emissions. No, in the reality, no tailpipe emissions, but life cycle emissions is exist. Battery production, electricity generation sites, we are generating the emissions. EV battery can be recycled. Yes, we can recycle the EV batteries, but it's very hard to recycling it and very expensive, too expensive now in current technology. So we have to be develop new technologies to do recycling EV batteries. EVs are always greener than ICEs. Reality depends on the energy mix. I mean that which energy resource we are using. EVs powered by coal-heavy grids offer limited benefits. EVs have short lifespans. No, normally the modern batteries last 8 to 12 years lifespan, and warranties offer cover 150 to 250,000 kilometers. Highlighted proven benefits of the EVs are lower emissions, significantly reducing the carbon dioxide and air pollution is over life. Noise reduction, as we talk about that, quieter operation improves urban environments. Economical cycle low operating cost we had. Energy independence, less reliance on imported oil, more integration with the renewables. If we can put new renewable energy plants on the system. And the social side, public health side, cleaner air, lower rates of respiratory and cardiovascular disasters. Innovation on the driver side, sometimes new industries in batteries, software, and green energy. And unsolved challenges of future outlook, battery recycling challenges are effective battery recycling is critical and reduce environmental impact and recover valuable materials for electrical vehicles now. With integration issues we had, integrating electrical vehicles into power grids requires innovation solutions for energy management and stability because our current electrical grids are very old and couldn't support this requests. Raw material sourcing side, sustainable sourcing of a raw material is essential to support electrical vehicle production without depleting the resources. And innovation and policy support is required. Continued innovation and support policies are key to overcoming challenges and advancing the electrical vehicle sustainability. And there's a graph here, you are seeing that global new vehicle sales and cost and protection side. And if you see that on 2022, 66 million vehicles sold all over the world, but now 91.6 million vehicles will sell all over the world. That showed that also electrical vehicles is changed the marketing size and get much more requests from the buyers. So also we have to be focused on the raw material usage and raw material requires of the producing that kinds of number of vehicles. Comparing the previous year, we will see that 23% more vehicle we will sell in the global side. As a conclusion side, EV adaptation is in global EV sales grew from 10 million to 17 million, reaching 22% of market share now. And on sustainability balance, EV sales reduce tailpipe emission, but shift dependency to critical minerals and battery cycling. Life cycle reality, higher production emissions offset by lower operational emissions when powered by the clean grids. Economic factor side, EVs have higher upfront costs but lower operation and maintenance costs. Battery replacement remains a critical factor on EVs. Infrastructure antiquity, changing networks, grid capacity, and affordability are vital for inclusive transformation. Final insight, we can say that EVs are not perfect solution, but a translation technology towards sustainability mobility. Their long-term benefits depends on renewable integration, battery cycling, and equity access. Yes, if you have any questions, I would like to answer it.
Thank you very much. There's a question. What key parameters should be considered when evaluating the sustainability claims of electric vehicles?
Yeah, as I said on the presentation that electric vehicles help us to reduce the pollution, but in the other hand, it affects the using of the raw material sites and generate a big carbon footprints on the manufacturing. So we have to balance them together to continue to do electrical vehicles.
Okay, and the next is how might electric vehicles intersect with or influence the aviation sector in the long term?
It's a good question because as we know that we are still working on the electrical or next generation aircrafts now. But here we have to focus on the battery weights. In current electrical vehicles, we are using at least 500 kilograms battery packs for a few kilometers comparing to the aircrafts. So that kind of weights is also requires much more power on the aircrafts. So first of all, we have to develop new battery technologies, which is much lower weight and higher capacity to use on aircrafts, I mean, on the aviation side. But in the other hand, also, we started using the electric vehicles on the ground support equipments like tow bars, like trucks and that kinds of things on the apron side. But I believe that we have a few more time to use the electrical systems on well balanced on aircrafts.